Okay, up to here you have seen how we can find different properties for air, and we have seen the temperature and humidity of the air are important properties, and we need to evaluate these properties of the air, especially for air conditioning system. Now we are going to continue our discussion, and we are going to introduce different type of air conditioning system and see how the air properties change in an air conditioning system. But before we continue, we need to see why we need to have air conditioning system. As you know, uh, today the modern air conditioning system can heat, cool, humidify, dehumidify, clean, and even deodorize the air. And in other words, it can condition the air based on the people desire. So because of that, we call them air conditioning system. And we need these systems basically to provide a comfort environment for human beings. As you know, the our body, the human body, needs a specific uh, temperature and also humidity to feel to be which is in a comfortable environment. Based on the experience, human beings found out that we cannot change the weather, but we can change or control the uh, climate inside a closed space. So we have invented the air conditioning system. The initial air conditioning system just changed the temperature of the and space. For example, increase its temperature, heat like heater, uh, or decrease the temperature of an closed environment actually. And we use this system initially to just change the temperature and bring the temperature of the environment or climate of the space which we are in that space to the our desirable range. Based on the different studies, we have a range of the temperature which is we call that comfortable region of the temperature for human beings. And also we have an a specific range of the humidity, which is the desirable humidity level, actually relative humidity, which is desirable for human beings. And this temperature and this temperature range and humidity range is determined based on the human properties. As you know, we can model the human body as a heat engine, which receive energy uh, from foods and release extra energy as the heat dissipation from our skin, for example. So this heat dissipation, if the temperature or and relative humidity around us will let us to dissipate this amount of the energy exactly, which we need to release to the environment, that environment will be a comfortable environment for us. So and this also, the amount of heat which is dissipated from our body depends on our activity, and we will dissipate these extra heat from our body by two different ways. First of all, by perspiration as latent heat, which we sweat, and the droplet of the sweat on our body will evaporate, and this evaporation will absorb temperature from our body. And also, the other half is dissipated through convection and radiation as sensible heat. You may have this experience once you are um, in a room and you will receive the temperature by radiation from sun, for example. So by these two ways, we receive or release temperature, and this will determine the desirable temperature for our body. And this is what I told you. We cannot change weather, but we can change the climate in a confined space by air conditioning system. And also, as I told you, a body feels comfortable when it can freely dissipate its waste heat. This is important, and not more. If we uh, release more heat, we may feel the environment is cooler than our desirable. And mm, if we release less than temperature which we need to release, we may feel the environment is uh, uh, the temperature of the environment is higher than our desirable temperature. So, in this is one criteria which we need to consider the temperature and also the humidity, which are the main stimuli to invent these air conditioning systems. And also, the other important factor on our comfortable level when we are in an air conditioned space is the speed of the air or the speed of the air around us, which is effective on our feeling about the temperature. For example, in an environment at 10 degrees Celsius with 48 kilometer hour winds as the speed of the wind, we feel as cold as an environment in negative 7 degree Celsius with 3 kilometer per hour winds as a result of the body chilling effect of the air motion, which we call that wind chill factor. So the other factor which is effective on our feeling about the weather is the speed of the air. So once we are going to design an air conditioning system, we need also to be careful about the speed of the air around us. So now we are going to define a comfortable level. The comfort of the human body depends on primarily on three factors: the dry bulb temperature, the temperature which we can measure by a thermometer, relative humidity, and also air motion. This is what I told you as well. These three factors are primary factors which are effective on our comfort level in any space. But what should be what is the comfortable range for each one of these properties? As I told you, we have a range of these properties which may feel that that environment is comfortable for us. First of all, the relative humidity affects the amount of heat a body can dissipate through evaporation, and the comfortable level is 40 to 60%. Most of the people find this range of the humidity comfortable for them. The other parameter is air motion. Air motion removes the warm, moist air that builds up around the body and replace it with fresh air. Air motion should be strong enough to remove heat and moisture from the vicinity of the body, and also it should be gentle enough to be unnoticed. So this is our criteria to design the fan speed or the air speed around us. The other important factor is which is effective on the human comfort is heat transfer by radiation between the body and the surrounding surfaces such as wall and window. This is also important once we design a air conditioning system. Other factors which are affecting our comfort level are cleanliness, odor, and noise, which we are not going to discuss about them. Uh, now, after this, we will continue our discussion to mainly focus on these two parameters: the temperature and also relative humidity, which are two important factors for air conditioning system, and we will more discuss about them. We will also use psychrometric chart to see how the properties of the air will change in different type of the air conditioning system. So you can see here why we need uh, to have air conditioning system, because they can provide a comfortable environment for us. They can set humidity level and temperature level, uh, and bring that temperature and humidity to our uh, comfort level. So after this, we will go and see different type of the air conditioning system. Okay, you have seen why we need to have air conditioning system. But what is really definition of air conditioning process? Maintaining a living space or an industrial facility at a desired temperature and humidity requires some process, which we call them air conditioning process. So this is definition of these air conditioning process. And as I told you, the air conditioning processes or system which we are going to talk about them are mainly effective on the temperature and humidity of the environment. So these air conditioning processes which we are going to discuss about them are include simple heating, which we just increase temperature of the air in the air conditioning system, rising the temperature. Simple cooling air conditioning process, which we just lower the temperature of the air. Humidifying, uh, or the we may have air conditioning system which change the temperature and also change the humidity of the air simultaneously. And so we will have some air conditioning system which they humidify the air, and also they add moisture to that. And we have also air conditioning system which they change the temperature also and change the humidity by dehumidifying or removing moisture from the air. And you can see also these different processes, various air conditioning processes in these imaginary psychrometric chart. You can see for the simple heating process or simple heating air conditioning process, we have uh, a change in the properties of air like this. The specific humidity remain constant. Only its here is the dry bulb temperature. Only dry bulb temperature of the air is increased. Simple cooling, air conditioning process, only again the relative humidity, the specific humidity will remain constant. Only dry bulb temperature is reduced, as you can see here. On this axis we have dry bulb temperature, TDB, and here we have omega. So omega remain constant. TDB in heating is increased, and in cooling, simple cooling is decreased. And also we have some air conditioning processes which just include humidifying or dehumidifying. Simple humidifying, only the omega is changed in these processes. As you can see here, specific humidity is increasing by adding moisture to the air when the air is dry, for example, and we are going to increase the humidity of the air, or we dehumidify the air and we don't change the its temperature, so it will be like this in this chart. And if we have an air conditioning system which we uh, heat or increase temperature of the air, and also we humidify or add some moisture to the air, then will be like this. Omega is increased, dB, TDB also is increased. So moisture content and also the temperature or dry bulb temperature of the air will increase, and it will be like this in the psychrometric chart. And in reverse direction, cooling and dehumidifying will be like this, removing temperature and reducing the temperature, removing the moisture from the air will be like this in the psychrometric chart. So you can see why psychrometric charts are important. Simply, we can show different air conditioning processes in a psychrometric chart. and it is mentioned also here. And we will also consider the uh, mass also, and also energy based on the first law of the thermodynamic. We will check the air conditioning processes, the conservation of the energy, and mass also will be checked for these different processes. Generally, for different air conditioning processes, we can assume that we have a steady flow process, and the following mass and energy balance equation generally can be used for them. The mass balance, we have a mass balance for in our system, m dot in equal to m dot out. And in air conditioning system, we have air and water to the system, so we need to write mass balance for our system into different fraction, for mass balance for dry air, mass balance for water, which they will uh, make our air standard. So if we write mass balance for dry air, we can write like this: m dot summation of m dot a in, or all of the masses which come to our uh, air conditioning system will be equal to the all of the masses which goes out of the system, mass of the air actually. And similarly for water, mass balance for water, we can write all of the mass flow rate of the water which come to the system is equal to mass flow rate which goes out of the system. But you know that we can write m dot w based on the omega, or specific humidity. We can, this omega is equal to m dot w divided by m dot a. So simply we can change this equation and write the mass balance for water based on the specific humidity of the air, and also mass flow rate of the air. So summation of the m dot a times omega, which is mass flow rate, the specific humidity of the air, input and output, it should remain constant. So we have this equation as mass balance for water in an air conditioning system. And to write energy balance equation for this steady flow process, or for this air conditioning steady flow process, we can write Q dot in plus W dot in. As you know, the general equation is like this: E dot in is equal to E dot out. And here we need to assume that the kinetic and potential energy, the change of the kinetic and potential energy is 0. And also here, Q dot in plus W dot in plus summation of the M dot H. This is for amount of the change in these two terms shows how the energy of the system change due to the mass flow rate to the system and mass flow rate which is from the system. Q dot in, W dot in, and Q dot out and W dot out are the amount of the heat which is come to the system, or the work which is done on the system, and also Q dot out the heat transfer rate which goes out of the system, and W dot out the work which is done by the system, which is 0 generally for the steady for air conditioning system. Generally, we have this uh, work term, or W dot, usually consists of fan work input only, which usually the change of the amount of the this work based on the joule is uh, negligible compared to the change in the energy of the system due to the mass flow rate of the air. And if we have water, we will see in the system with the dehumidification and humidification system, and we will see in those kind of system which we have water to or from the system, then this amount of work actually is negligible compared to the change in due to these two terms. So usually these W dot in, W dot out are ignored, and what we have will be just change in the energy of the system. We will see in that in form of the change in the temperature of the system, and also these terms which contains a mass flow rate of the uh, air and water to or from the system. Okay, now you have seen the equation which we need to evaluate different type of the air conditioning system and process. So let's begin to with the most simple type of the air conditioning system. Simple heating and cooling air conditioning system, which we can call them also the constant specific humidity air conditioning processes, because the specific humidity remain constant in these processes, which I have already told you in previous slide. And why this system is interesting and how it changed the temperature only it changed actually only the temperature of the air and not its moisture content, but it is still it can be useful especially in the residential heating system. So many residential heating system consist of a stove or a heat pump or an electric resistance heater. These different type of the its source actually are being used in this air conditioning system. You know the reason why we have these different type of the of this stove, heat pump, and electric resistant heater in previous chapter. The air in this system is heated by circulating it through a duct, like what you can see here. Imagine it is a duct. We have air inside this duct. The air in this system is heated by the circulating through a duct that contains the tubing for the hot gases or electric resistant wire. So if we have a simple heating air conditioning process, then we have air inside the tank, it will circulated around a heating coil, which this heating coil can be some tubes contain hot gas, or it can be electric resistant wires, which their temperature is higher than temperature of the air. Then, due to the heat transfer between the air and these wires or coils, temperature of the air also will change. And because here we are going to increase the temperature in heating, a simple heating air conditioning system, then this temperature of these coils should be higher than temperature of the air. So in heating, simple heating air conditioning system T1, which is temperature of the air before the it comes to the air conditioning system, is less than temperature of the air at the exit of the air conditioning system. In other words, in such a system, temperature of the air will increase. But omega or a specific humidity of the air will remain constant in this heating process, as you can see also in this. However, the relative humidity will change. You know about the relative humidity? Relative humidity is the amount of the uh, humidity which the air contains divided by the saturation humidity, maximum humidity which air in each temperature can hold. So here, because temperature is increased, so phi or relative humidity is changed, and phi 2 or relative humidity at the state 2 after this heating process is less than phi 1. In other words, relative humidity in this heating process will reduce. This is for heating process. During simple heating, specific humidity omega remain constant, but relative humidity decreases. Phi 2 will be less than phi 1. How about the simple cooling process? simple cooling process, you know, the procedure is same, more or less same. We have again a duct, but here instead of a heating coil, we have cooling coil. We may have some coils which through which a refrigerant or chilled water flows. You already know how we can, what is refrigerant from a previous chapter, and how we can provide the uh, refrigerant here in these coils from previous chapter. You may know that. So in that case, our purpose is to reduce temperature of the air in our simple air conditioning system. In that case, T2 will be less than T1 for a cooling or simple cooling air conditioning system. But for uh, again, omega will remain constant or specific humidity. What change during this process, beside the temperature, is relative humidity. So during simple cooling, specific humidity remain constant, omega remain constant, but relative humidity will increase. So in this case, phi 2 will be higher by 1. So relative humidity will change during this process. The temperature change, but relative humidity also changes. So, you know, but usually we may not be interested to change the relative humidity, and we may just be interested to change the temperature of the air in the air conditioning system. But as you can see here, in this simple cooling or heating process, amount of the phi or relative humidity is not under our control. And you know that also this humidity is effective on our comfort level. I mean, relative humidity is important for us to keep an environment comfortable for human beings. So, if we are interested to control the relative humidity in an air conditioning system, we need to design different another type of the air conditioning system, which I will discuss about that later. But now here, let's see how is the simple heating or cooling air conditioning process in a psychrometric chart. As you can see here as well, as I told you, the in a simple heating or cooling air conditioning system, the temperature or dry bulb temperature of the air will change, as you can see here. For example, in a heating, simple heating air conditioning process, temperature is increased from 12 to 30 degrees Celsius. And you know, we have omega here, and omega here is equal to omega 1, omega 2. So omega or relate or specific humidity doesn't change. For example, if we have uh, heating process, or even we have simple cooling process. So if we are going to increase the temperature from 12 to 30 degrees Celsius, then by a simple heating process, omega remain constant, but its temperature change. And also you can see the the relative humidity also is changed by change in the dry bulb temperature. So by this also we can understand from this psychrometric chart, we can also understand how the other properties of the air change will change during a simple heating or cooling process. As you can see here on this psychrometric chart, you can see that we have changed the temperature, the bulb temperature, and but the omega remain constant, phi will change, and other properties also we can check here in the psychrometric chart. Now let's write the uh, our equation for the mass balance and energy balance equation for these simple heating and cooling processes. As I told you, the general equations are here. We have already found them. So let's write those equation here for our system. If we select our system, for example, like this, then we have a steady flow processes. We have in here, out here, so we can find this equation for that. Again, dry air mass balance here, m dot A1 is equal to m dot A2. as the air which come to the system is equal to of the air which go out of the system at the state 2. So m dot a1 is equal to m dot a2 equal to m dot a, it should be actually. How about omega? Omega remain constant in the process. So if you notice, we had this equation, mass balance for water, sigma m dot a omega here. Now in our process, because we have single input, single output, so it will be like this only, m dot a 1, 2, 2. And if you notice here, that A1, A2 are identical, so simply omega will be equal to omega, for example. Omega 1 will be equal to omega 2. Based on this equation, we found this equation for our simple heating or cooling process. How about energy balance equation? If we write this energy balance equation for our system, you will understand that what changed here, as I told you, uh, Q dot, or the change in the energy of the system, will be equal to m dot A, or mass flow rate of the air times the enthalpy of the air at the state 2 minus enthalpy of the air at the state 1, or entrance of these air conditioning systems. So Q dot will be equal to m dot A H2 minus H1. Here, because if we have heating, Q dot is added to the system. If and it will be positive. If we have cooling, then Q dot is removed from the system, and the energy is released from the system. So in that case, in any case, Q dot will be equal to m dot A times H2 minus H1, enthalpy at this state minus enthalpy at this state, which simply we can find enthalpy of the air by psychrometric chart, or we can use our equation, which we have seen already in previous sessions, to calculate enthalpy of the air. Then finally we can find Q dot, or Q, or amount of the energy which is absorbed or released during this cooling or heating or cooling process. In next slide, we will discuss about the heating or cooling process with humidification or dehumidification. Okay, so based on what you have seen in previous slide, we can use simple heating air conditioning system or process to increase the temperature of the air to bring it to our comfort level. But unfortunately, when we increase temperature of the air, its relative humidity will decrease, and it means the relative humidity will maybe go out of the our comfort level. It will go down from our comfort level. So one possible method to also keep the, or to increase the relative humidity of air in a heating process is to add some water or some moisture to the air again. This kind of the system is called the air conditioning system, or heating and humidification air conditioning system. This is topic of this slide, which I'm going to tell you more about that. In this system, if you remember, we similar to what we had for a simple heating uh, air conditioning system. Again, we have a duct, we have a flow of the air, and also we have that heating coils or resistance wire and so on to increase temperature of the air. But what is added here is a humidifier, which can add some moisture or water to the air after its temperature is increased, to increase its reduced relative humidity actually. So in this case, we need to evaluate the air or investigate the properties of the air at three states, not two states. First, before it come to our air conditioner, then after the heating coil, here temperature is increased. Then we have added an humidifier, temperature is increased here, and finally stage three, which is the exit of the our air conditioning system. In other words, we have solved the problem of the low relative humidity of simple heating air conditioning process by adding this humidifier. And you can see here how omega is changed in this system. In a state 1 to a state 2, similar to the simple heating uh, air conditioning system, omega remain constant. But after that, in this heating and with humidification air conditioning system, we add water. This is external water. And it will be effective on the specific humidity, and it will change specific humidity. So due to change in this specific humidity, the relative humidity also will change. In other words, by adding this humidifier, omega 3 or a relative humidity at state 3 will be higher than the specific humidity at state 2, because some water is added to the air here in uh, to, uh, our air conditioning system. So simply, these problems with low relative humidity resulting from simple heating can be eliminated by humidifying the heated air, like what you can see here. This is accomplished by passing the air first through a heating section, this section, and then through a humidifying section, this section. So we have a heating section and we have a humidifying section. Now let's see this process, the equation for this air conditioning process. First of all, mass balance equations for this process. Dry air mass balance, you can see here, air doesn't change in this process, its mass flow rate remain constant. So for dry air, we have m dot A1 is equal to m dot A2, which we have here totally is equal to m dot A. How about water mass balance? Here, m dot A1 for this heating section. Actually, we write this m dot A1 omega 1 will be equal to m dot A1 omega 2. Again, if you remember, we have developed this equation for a general air conditioning system. And again, for this part, for this heating section, omega 1 will be equal to omega 2. Then if we want to write energy balance equation, here again we have Q in, which come from these heating coils. So we can write Q dot in plus M dot A H1, which comes, this is the energy flow energy, actually, if you remember from thermodynamics, which come from the air. M dot A1 H1 enthalpy of the air, M dot A is mass flow rate of the air, equal to state 2 M dot A H2. This equation is for this section, heating section. If we rearrange this equation, we will have like this. You can see here the energy in the system, in this heating system, or totally in this air conditioning system, the energy change due to only change in the this temperature, this heating process. The change in the energy of the system due to this water which come to the system and so on is negligible compared to this. If we want to write the mass balance equation for this region, the humidification process, we can write m dot A2 omega 2. This is due to the air which is flowing to this section, from this entrance to this section, plus m dot omega m dot W. This is the mass flow rate of the water which is sprayed to this region. So m dot W is an added water to the standard air which we have, it will be equal to m dot A3, the mass flow rate of the air at the state 3 times omega 3. Omega is the specific humidity at the state 3. If we rearrange this equation, the mass flow rate, which we require here to bring the specific humidity to omega 3 is this much. M dot W, the amount of mass which we need to spray in this region, is equal to M dot A, mass flow rate of the air, times omega 3 minus omega 2. Omega 2 is also equal to omega 1, if you notice. So simply, if we know what is our desirable specific humidity, then we can calculate also this m dot W, or mass flow rate of the sprayed air here in the humidifier. And this is the equation which we also use in our calculation. After this, we will see an example, and we'll see how we can use this equation to calculate these required mass flow rate of the water, for example, and the other properties for a air conditioning system, the heating with a humidification air conditioning system. The last thing in this slide is about this process in a psychrometric chart. This part, this is for heating section. The temperature, the dry bulb temperature is increased. Omega is constant. Omega 1 equal to omega 2 equal to omega. And this part from state 2 to state 3 is this humidification section. In this section, temperature is again increased, and also its its specific humidity is increased, and at the same time, its uh, relative humidity also is increased, as you can see here. The specific humidity is increased, so its relative humidity also is increased, as you can see here. So this is uh, uh, actually heating with humidification process. It include a, simple heating process and a, humidification process. So this is also the graph of this process in a psychrometric chart.